Emulsions and emulsifying agents. Aim: to study the role of emulsifying agents in stabilizing the emulsions of different oils. Apparatus required to perform this experiment are 5 test tubes with corks, 5 droppers, test tube stand, and stop clock. Materials required to perform this experiment are kerosene oil, mustard oil, machine oil, castor oil, and coconut oil. Take 5 clean and dry test tubes and name them as A, B, C, D and E. In each test tube, take 5 ml of different oils. Here in test tube A, we took kerosene oil, test tube B, mustard oil, test tube C, machine oil, test tube D, castor oil, and test tube E, coconut oil. Now add 20 ml of distilled water to the test tube A. Shake it vigorously for a minute and then allow it to stand. Here, you need to note down the time taken for 2 layers in the test tube to separate out. Here you can clearly see the time taken by test tube A is 8 seconds. Now similarly, repeat the procedure and note down the times taken for test tubes B, C, D and E. Time taken for test tube B containing mustard oil is 23 seconds. Test tube C containing machine oil is 10 seconds. Test tube D containing castor oil is 30 seconds. Test tube E containing coconut oil is 60 seconds respectively. Now add 10 drops of soap solution to the test tube A. Shake it vigorously again for a minute and then allow it to stand. Note down the time taken for layers in the test tube to separate out. Here you can clearly see the time taken by test tube A is 12 seconds. Now similarly add 10 drops of soap solution to the rest of the test tubes and repeat the experiment. Time taken by test tube B containing mustard oil is 16 seconds. Test tube C containing machine oil is 10 seconds. Test tube D containing castor oil is 17 seconds. Containing coconut oil is 22 seconds respectively. Now tabulate the time taken for 2 layers to separate in each case, that is without soap and with soap. From the observation table, it is clear that the coconut oil takes longest time to get separated from its emulsion, and kerosene oil takes minimum time.
Hello students. In the previous video, we discussed on the examples of colloids around us. Let us discuss its application through this video. As we know that a lot of smoke is released from an industries through chimneys, which causes air pollution. As smoke is a colloidal solution of solid particles such as carbon, arsenic compounds, dust, etc. in air. So, the smoke which comes out from the chimney, first it is made to pass through a chamber containing plates having a charge opposite to that of smoke particles. So, the particles when it come in contact with this plate loses their charge and get precipitated. So the particles settles down on the floor of the chamber, and the precipitator which is used for this purpose is called as control precipitator. So in this way, the smoke which is given out from the chimneys, from that the particles, dust particles get removed. What about purification of water? As we know that the water which is obtained from the natural sources often contains some suspended impurities. So when we add alum in the water, it coagulates the suspended impurities and make the water fit for drinking. Medicines. Most of the medicines are colloidal in nature. For example, eye lotion, intramuscular injections, milk of magnesia, which is actually a emulsion used for stomach disorders. So why the medicines are actually more effective when they are in the colloidal solution? Because they have larger surface area. As larger surface area, more will be the effectiveness of these medicines. Next is tanning of leather. Leather is made up of animal hides. Animal hides are colloidal in nature. When an hide which is positively charged particle, having positive charge particle, when it is soaked in tannin, tannin having negatively charged particles. So that means both have opposite charges and both are sold. So when it gets mixed in this, a mutual coagulation takes place that results in the hardening of leather. So this process is called as tanning. The next application, cleansing action of soap and detergent. This is we have already discussed, that is due to the formation of micelles. In the rubber industry, the latex, we know that rubber we are getting from rubber trees and which gives latex, and this latex is actually a colloidal solution of rubber particles which are negatively charged. So these rubber is actually first it should be coagulated, then only it will get coagulated, then only we can do the processing. So it should be coagulated, so that means it is also colloidal in nature. A lot of industrial products like paints, inks, synthetic plastics, rubber, cement, all are colloidal solutions.